Welcome back to the shop. This is the first video in what will ultimately become a series of videos using Fusion 360 to design a woodworking project. This particular project is a cabinet with multiple drawers and doors on hinges. We'll be using two different types of drawer slides and actually putting some electronic components into it as well to provide lighting for the cabinet. The cabinet here is shown on the screen. It is actually a bar cabinet, but this could be anything. It could be a wardrobe, it could be a dresser, could be a kitchen cabinet for that matter. I picked this particular project because I want to be able to illustrate some more advanced features of Fusion 360 in actually going about this design, in particular the parametric workflow techniques, as well as exposing a number of pro tips on use of Fusion 360 techniques as we go along throughout the project. So I made a big deal about this being a parametric workflow, so let me just say a few words about what that means. It means that the design of the project here is going to be driven by a set of parameters that we're going to create that control things like the dimension of parts, the thickness of components, how one surface relates to another, how various parts within the 3D model are positioned and relate to each other. You can think of these parameters kind of like a spreadsheet that drives the design. It's nothing more than a table of parameter names with values and some commentary if you want to add that. The primary advantage of this kind of design is that at any time you can go into this table of parameters and change things like dimensions, and that change to the parameter will ripple through the entire design of the model and update things automatically. So if you were to design a cabinet, for instance, that was 20 inches deep and you or your client decides, no, I'd really rather have it 18 inches, then you can change the parameter on the depth of the cabinet, and if you've done the design correctly, everything will update automatically, including the depth of the drawers, the sides of the cabinet, the size of the top, all of those attributes. So that's what we're after here. I want to spend just a second here on some commentary about my desktop tools in the physical workspace that I work in. To use Fusion 360 effectively, you really need a 3-button mouse with a wheel. I happen to use one by 3D Connections, but pick your favorite brand. I do like a full-size keyboard because we're entering numbers quite frequently here in sketches and things of that nature. The other aspect that I use is something called a space mouse. It's also made by the same company, 3D Connections in the UK. It's a puck that sits on the opposite side of the keyboard and is controlled with your other hand, and it allows you to manipulate the model as you're viewing it by zooming in, zooming out, rotating the model, turning it around, all kinds of things. You can do those functions using a regular mouse and a bunch of option keys on your keyboard, but I much prefer this. I find it more intuitive. It's not cheap, it's over $100, but since I spend almost 40 hours a week doing this kind of work, I much prefer this to the traditional manual method of manipulating the view of the model within Fusion. The other thing I'd like to point out is that throughout this whole series, you'll see a consistent use of toolbars that I have arranged the way I like to work. You can arrange the toolbar yourself however you want, but this is the toolbar I use for design, the toolbar I use for sketching. And you can add or remove tools or rearrange them however you want within Fusion. The other thing I'd like to point out is the visual environment that I like to work in has shaded model features in what Fusion calls a photo booth style, which is basically a white background. I like anti-aliasing turned on. I like all of the objects to be visible. And most importantly for me is when I'm looking at a 3D structure, I want to see it in perspective with orthographic views of the surfaces. The other thing which isn't shown here is that I don't like working from a grid structure like graph paper. I much prefer to work in an open space, which you'll see as we go forward. So let's move on now with that introduction into let's start creating something. Okay, so here we are in Fusion. We've got a workspace here. We're in the design workspace, and We have our data panel open over here. You can see we don't have any saved projects yet. We'll get to that in just a second. I spoke earlier about the display settings and that sort of thing I like to use. That's all controlled down here, in case you didn't know. I do occasionally put comments in, so I'm going to leave that there. The one thing I do want to show you is how to add something to the toolbar. Chances are your toolbar doesn't look like mine, but if you want to organize yours like this, you can. So I'm going to just click on that little down arrow there, and here are all the tools, and you can put any of those up there by going down. I want to put change parameters up there, and there are 3 little dots right next to that, and if I click on that, I can say pin to toolbar, and now it shows up there. So that's a quick view of how to reorganize your toolbar. You can do the same thing in the sketch environment as well. Okay, so most people will tell you rule number 1 with Fusion is work inside a component. So let's start that process now by creating a component that we're going to be working inside. Right click on there, new component. Now we can give it a name. I'm going to call this bar cabinet. There it is. There's not much in that component yet, just an origin. I'll talk about that in a minute. Let's save it. Command or Control S on the keyboard, and we're going to give that a name, bar cabinet. And you can see it shows up over here in our data panel. We're at version 1. Every time we save, we'll get a new version here. I don't need this data panel open at this point, so going forward, we'll be using it as we move along, but for now, let's just close that so we get a bigger workspace here. So I'd like to first create a transparent model of the outside dimensions that the client gave as maximums. So we can do that. Let's create a sketch, and let's put it on the bottom panel here. Might as well talk about the origin here for a minute. Let me turn it on. I like to work in a coordinate system where the blue or z-axis is up, the red or x-axis is right to left in the design or side to side, and the green axis, also called the y-axis, is front to back. That's just my preference. So we're going to create a sketch on the bottom plane there that represents the width and depth of the cabinet as specified as maximums by the client. So we're going to do a single point, center point rectangle. If you don't have it on your toolbar, it's right here, and you can add it with those 3 buttons just like I talked about before. So we're going to use that. We're going to pick up that point in the middle, come out, and that's going to represent the maximum size of width and depth of the cabinet. We'll get to the height here in a minute. I want to drive this with parameters rather than putting specific dimensions into this sketch. So let's do that. Let's Let's create our first set of parameters here. This little plus sign here will allow us to create things, and we can specify units and all that. So max underscore width, that was given to me in inches, so we'll select that, and it was 29.5 inches. So we'll add that. There it is. Let's do another one. Max depth, and that was 22. And then max height, also given to me in inches, was 76. So there we are. Now we can use those parameters to drive this sketch. So we'll say OK here, and it's time to put those dimensions on this. So D for dimension on the keyboard. We're going to define this as the, now we can just start keying in, and we get a drop-down list of things that have the letter M in it. So max width here of 29.5, and D again for this side, and this is M for max depth. So that's the profile of the bottom of the cabinet, maximum as defined by the client. We're going to use that now to create a component that represents those outside limits. So on the keyboard, E for extrude. We're going to extrude this up. How far are we going to extrude it? Well, we're going to extrude it M max height, right there, 76 inches, and we're going to create a new component, not a body. So there it is. Now I've got it colored because I've got the inspect tool set to display component colors. If you don't have that turned on, you're going to get a series of gray boxes like this. So I prefer to have that display component colors on, because then every component that's created in here will have a different component that's tagged by the lines on the top of the elements in the timeline, and also inside the browser. So you see this green line there represents the green color of that component. Helps. It's not necessary, but I like to use it that way. So that's our maximum. Let's do a couple things here. Let's first, I am a big believer in labeling your pieces in the browser here as you go along. And the reason is because you come back to this the next day and you wonder, where's the sketch for the bottom of the cabinet? And if you've got nomenclature that's sketch 1, 2, 3, 4, that's not going to be very helpful. So let's just change the name on that. 2 slow clicks on it and you can enter a new name. Max bottom profile. And while we're at it, let's give this component that we just created a name as well. 2 slow clicks. Max outside dimensions. So there we are, and we can turn this on and off. We've got the 3 things that created it here in the timeline: the sketch, the create component, and then the body within it, created with an extrude. We could go back and edit those if we wanted to. For instance, let's edit that feature. Now we can go back and change these things again. That's the beauty here. All right, so that's our maximums. We'll use that in a different way here in a minute. Let's start working on the cabinet itself. And I like to start on something like this at the bottom and work up. So I'm going to turn that off, and I'm going to do a right click here, and I'm going to create a new component again. And this is going to be the cabinet case. And that will include the top, bottom, 2 sides, back, and legs. So let's just do that. So let's create a sketch of the cabinet profile starting at the bottom. We'll do a create sketch here, and we'll do this on the bottom plane, which is right there. I'm going to use a center point rectangle again, and we'll pick up the center there, and we'll come out. I'm going to draw the bottom panel first. We'll come back in a minute and put in some dimensions. So if we pretend that's the bottom panel, we want 2 side panels. Whoops, I don't want to use a center point rectangle there. I want to use a regular rectangle. I want to pick up that corner, come down here. We'll say that's the side. We'll put some constraints on that in a minute. This is the other side over here. Pick that up. There we are. Now, good rule of thumb here is to try and use constraints as much as possible rather than dimensions. So one of the things we can do is say, let's use the collinear tool and say the front of the side is collinear with the bottom. We can do the same thing on this side, front of the bottom. So we got 2 sides and a bottom panel. We need to put some dimensions on this. Let's talk about that for a second. A couple things come to mind. I would like to keep these side panels, the overall depth of the cabinet, to under 510 millimeters, because that's the maximum capacity of my joiner planer. Remember, this is going to be done in hardwood, and I'd like to be able to glue up a bunch of hardwood panels and pass the whole thing through the joiner planer and then trim it to size. So let's create a couple of parameters here. Let's say that the cabinet inside the depth of the cabinet is 490 millimeters. You can see I've already done that. And I've temporarily created another one here called cabinet inside width of 27 inches. We'll get back to that here in a second. So the thing that's going to drive the width of this more than anything is the bottom drawer. I outsource all my drawer boxes from a third party. They build it to any specification I give them, but they like to talk to me in imperial rather than metric. So to keep things simple with them, I try and, where possible, make my drawer widths and depths whole inches. So let's just say, for example, that the drawer width here would be 27 inches. That'll certainly fit inside the maximum limits given by the client. So I've defined that here with a cab inside width of 27 inches. And it's not going to be just that. It's going to be a little wider because of the space required on both sides of the drawer box for the slides or runners. So we need to figure out what that is. Let's do that next. I'm going to go off to a drawing here that will give us that information. So for this project, I'm going to use Salice undermount drawer slides for that bottom drawer. It's going to hold lots of bottles of liquid, so it needs to be pretty stout runner system. This particular slide from Salice is part of their Progressive Plus line, and they'll take 170 pounds of capacity. So that's fine. It'll use a drawer box with sides either 1/2 inch or 5/8 or anywhere in between. So this is the diagram they're giving us about the relationship of the drawer box in the pink here compared to the sides of the cabinet. So what they're really saying is that the inside face of the drawer box side panel is 21 inches from wherever the slide runner mounts to the cabinet. 21 millimeters, sorry. So we'll use that 21 millimeters in determining the margin between the drawer box itself and the side of the cabinet. So let's go back to Fusion now and put in some parameters there that'll drive that. Okay, we're back in Fusion. Let's put in some parameters here. I'm going to give them some names. We've got drawer box side. If I could type thickness. We'll use 16 millimeter material here. My cabinet box supplier is fine with that. Let's do that offset. Drawer box side runner offset. And that was 21 millimeters. So we've got those two. I think we're going to do a drawer box that's 15 inches deep. I'm sorry, depth of the cabinet. So let's put that in. We can come back and change that later. Drawer box depth. And we'll put that in millimeters. So we'll say it's 15 inches times 25.4. That doesn't look right, does it? Let's do this differently. 15 inches. How about that? There we go. So we got those. And now let's go back to our sketch and start putting in some things here. Let's do another rectangle. This time I'm not going to use center point. You'll see why here in a minute. But I do want this to come in as construction geometry rather than hard geometry lines. We can do that a couple ways. You can click on it over here. That'll give us a construction line. Or X on the keyboard will toggle that on and off. So let's just draw something here that will be our sort of pretend. Whoops. Try that again. That'll be the pretend outside of the drawer box, and it's a construction line. So that helps. Now we have an offset tool here in our sketch tools, and we can say let's take that and let's offset it. And the distance here we're going to go to drawer side thickness. There we go. So that's 16 millimeters. You can see we've got an FX on there, which means it's derived from a parameter. Now what else do we need? Well, we know that this distance from the inside of the drawer face, from there to the side of the cabinet, that's that drawer box offset, 21 millimeters. And we know that's also true on this side. So let's put that in. We don't have to select, we can just click over here and duplicate that dimension on this side. So there we are, and we know the outside of the drawer box is 17 inches. I'm sorry, 27 inches. So that's this line right here. So we'll dimension that. Probably going to get something pretty weird here. Um, did we have a parameter for that? No. Let's do that. Let's create a parameter right now. We'll just let that be whatever it is. Width. Sorry, I didn't create a new one. I do that a lot. So we're going to do this. We're going to create drawer box width, and it's going to be in inches. And it's going to be, we're going to try 27 here. How's that? Okay. Might be good to, at this point, define the thickness, at least initially, of these side pieces that we're going to mill up from solid cherry. Let's add that as a dimension here. So we'll call that cab side thickness. And let's make that 20 millimeters. How about that? There we go. So let's put those in here. D for dimension. Let's make this the cab side thickness. We'll do the same thing over here. We can copy that one again. And then this one is not 330. It's the new parameter that we put in, which was drawer box width of 27 inches. There we go. The whole thing is going to scale up. There we go. And I talked about wanting this side piece to be about 490 millimeters deep. Did we make a parameter for that? Yeah, there we go, cab depth. So cab depth 490. So that's kind of our overall thing. Two sides, a bottom. This represents the drawer box on the lower part, at least side to side. We could dimension that drawer box depth here. Drawer box depth, there we go. Now it's actually going to sit inside this cabinet here somewhere, so we can drag that up just for visual standpoint. So there's our overall dimensions for the cabinet, at least to start out with. We could turn on the sketch for the maximum dimensions, which is right here. And we can see that we're definitely inside those parameters, even with 20 millimeter thick sides and a 27 inch wide drawer box. It's not as deep, but the client says that's fine. So there we are. So let's finish the sketch. At this point, we're going to drive up, we're going to create the components that represent the bottom and the sides. So we do that with an extrusion command, E for extrude. We'll pick this profile, and notice that it picked the whole outside of that rectangle rather than the drawer box inside. That's because the drawer box lines are construction lines. So it doesn't recognize those as valid for something like an extrude command. So anyway, we're going to extrude that at a distance, and let's assume that the top, bottom, and sides are all the same thickness. So we had a parameter for that, cab side thickness. There we go. And we want to create a new component. So if we look inside our cabinet case component, we have a new component here. We've got that sketch that we just created, and inside that component is one body right there. So let's name this cab bottom. Let's name our sketch bottom profiles. So let's create the sides now. We can turn that sketch back on, and E for extrude. We'll pick these two profiles. We're going to go up. We're also going to create a new component. And the distance here is our, we didn't define a new cab height. Okay, we can do that now. Let's cancel out of this. So let's go back into our parameters, and we don't have one here. So let's make a new cab height. And this is going to be without the legs. The legs I see on this will be about 4 inches. So I want this to be in inches, I don't know, something like 62 inches. Let's try that. We can always come back and change this later and have that update the design. So let's put that in. Now we can come back and create the sides. E for extrude. Side 1, side 2. We're going to create a new component. The distance is going to be cab height. There we go. And we've got it over here in our browser now. And we can name that cab sides. And now we want to do a top. So the easiest way to do the top would be to mirror the bottom component. Think of the mirror command in Fusion kind of like it sounds. We'll put a mirror up here, a reflection surface, and just reflect the bottom cab bottom component to the top of the cabinet. So to do that, we're going to need a reference plane that is the essentially the reflection surface. Let's turn off this sketch. So we can create a center plane between the top surface of the cabinet and the bottom surface of the cabinet now to do that mirror command. So construct, we can do a mid plane, and I want to go halfway between there and there. And there it is. So we can use that as our reflection surface. Now look over here. We have a new item that showed up in our browser called a construction plane. And right there it is. And we can turn it on and off. You know, we can come in here and do an edit feature and come back and redefine the two selected sides, and all the standard operations apply. Let's give it a name because we might use it in the future and want to know what this is. So this is a mid bottom to top. There we are. Now we can mirror that bottom component using that as our reference point. I have it in the toolbar up here, right there. I'm sorry. Do I have it here? Ah, there it is. So it's under Create, and it's down here if you don't have it in your toolbar. So we're going to mirror, and we're going to mirror a component, and the object it wants us to select is the bottom in this case, and then the mirror plane is that construction plane that we just made. So there's our top component. If we say OK, we got a new component over here in the browser. It's been labeled cab bottom mirror. Let's relabel it to cab top. How about that? I'm going to turn off this construction plane here. We're going to add another one here in a minute. So that's our basic box. Let's put a back on this thing. I see this back being a 12 millimeter thick cherry veneer faced plywood, and it's going to be let in on all 4 sides with a groove or a dado, and it's going to be slightly inset from the back face of the cabinet rim. So let's create some parameters to drive this. Let's do this. Cab back thickness, and we'll make that 12 millimeters. Let's do another one that defines the back groove depth. I'll put dado in there just so I know exactly what that is. How about 8 millimeters? That's let's do 9. That's no, let's do 8. I like 8 better. That's a little less than 3/8 of an inch. And then we're going to do a back face offset of, let's do 8 again. So now we've got those parameters in here. By the way, you can sort these by clicking on the heading there, in case I didn't say that before. All right, now I like to put sketches on construction planes rather than on actual geometry that's created in the model. So let's create a construction plane to do our sketch for the back panel. So we're going to do an offset plane, and we're going to offset from the back surface of the cabinet. We're going to go this direction, so it needs to be negative, as you can see over here. And that's our back face offset of 8 millimeters. So now we have that plane there. We can drag this out so we see its visibility, and if you look closely, can you tell? Yeah, you can tell it's inset. So we can use that to sketch on. Let's do that now. Sketch on that surface. Now we need, we want that back panel to be in reference to the inside surfaces of the cabinet rim. So there's a command in Fusion that can pick up those geometries. It's called project. So P on the keyboard for project. We're going to project that surface, that surface, that surface, and that surface onto our sketch plane. Now, you probably can't see it yet, so let's turn off the actual components, and there is what's been projected. And we're going to use those to size the back panel. But before we do that, I want to convert these projected sketch lines into construction geometry. You can see they're solid now, they're purple, which means they're projected, but I want this construction geometry rather than hard lines. And you'll see why here in a minute. So I'm going to use a mouse over, so if I just click and drag, I can pick that whole thing. Let's show you here, if you want to do a window selection, you can select that here, and I can swipe over the whole thing. Now it's selected all those elements, and I can click here, and those are now turned into construction geometry. You'll see why that's important here in a minute. Now the next thing is the back panel itself. Let's re-edit that sketch, and let's put a rectangle over it. That's going to be our back panel. Now we know that the back panel is offset into the sides, tops, and bottom of the case by that groove depth. So let's add that. So D for dimension. So relative to the side, this is the back groove depth. The same relationship is true here, and we can just click that. And another one here. And the last one. So now we can use that profile to create the back panel. We'll finish the sketch. But before we do, if you notice when I click on that, it picks up the whole back panel. If those projected lines were not converted to construction lines, it would pick up the inside rectangle rather than the outside. That's why I converted it to construction lines. So let's, we're going to E for extrude, and we're going to go inside the cabinet, and we're going to go to a distance of minus the back thickness. There we go. So there's our back panel. We want that to be a component. And let's label that now. Might as well name the this as well, back panel profile. Let's bring back our other cabinet components. So there's our cabinet box, and you can see, if you look closely here, it's inset. Now what's wrong with this? Well, it's a good time to use the section analysis tool here. So let's do a section analysis based on the edge of this, and we can drag in. And if you look closely, the back panel is in fact bigger than the inside of the cabinet case, but it overlaps it. So we need to actually put the groove in the top, bottom, and sides. And there's a handy tool in Fusion to be able to do that if you've already got something created as a component that can be the tool to cut the groove. So that is unfortunately named combine. It will combine things, but it will also do Boolean operations like find the intersection and delete surfaces and that sort of thing. So it's right here on my toolbar. It's under Modify, Combine, right there. So let's just do that. So it works in terms of a target body and a tool. So the target bodies here are the two sides, top and bottom. And it'll only do one at a time, and it'll do Boolean operations. It'll join, it'll cut, and you can keep the tools after the operation if you want as well. So let's do that with the top first. So the target body is the top panel. Let's just click on that, and the tool body is the back itself. And that's turned into this red translucent thing. That's key to you that this is a cutting operation that's going on. If we did a join operation, it would look differently. So we want to cut that, and we want to keep the tool. So the back panel doesn't go away on us. So we'll do that one. We'll do another one here. Combine. This is the target body. This is the tool. It remembers all the settings from the first use. Okay, now a little pro tip here. If you do a series of repeated operations, if you do a right click on your mouse and drag up like that, you get the last tool that you used from the toolbox. So bottom panel, and there's our cutting tool again. We're going to keep the tool, do a cut operation once more, side and the back. So now let's go back and do our section analysis again, and you'll see that it actually put the groove in the top and bottom. We can X out of that and look at it from this plane and come down, and it's done it to both sides as well. I hope that's obvious. So I think we have our box for our cabinet. We need to put some feet on it. We'll do that here in the next operation. I'm not exactly sure what kind of feet we're going to do here. The client said, gee, I like things that look solid and beefy. This is a big, tall cabinet. I don't want it looking like it's on wimpy legs. So let's create some legs here. Since we don't know what the client's going to really end up liking, let's create some parameters around it. To do that, let's do some sketching. So I want to create a sketch, and this time I'm going to use the bottom panel. So let's create another construction plane. Here we don't really have to do this, but I prefer it. And let's label it over here. Bottom face of cabinet. Oh boy, sorry. Bottom face of cabinet. Now we can use that as our construction plane for creating another sketch. So there's our sketch. Let's get some of the geometry of the cabinet projected here for us. Let's project, P for project. Let's project the two sides and the bottom. And just so you can tell, there's our projected stuff, and like I did before, I'm going to swipe over it and convert it to construction geometry. So now I'm just going to put in two kind of squarish legs here with a rectangle tool. There we go. Let's create some parameters that drive that, because we know they're going to change probably. So plus for parameter here, leg width is, I don't know, let's make it maybe 100 millimeters, about 4 inches. And then let's define how the leg relates to the cabinet sides, front and back. So we'll just call that leg offset. And how about if we make those 40 millimeters? See what this looks like when we get going. Let's try that. So let's put those dimensions in now. D for dimension. This one was the we didn't define that, did we? Let's take that out. That's not what we did. Let's remove that dimension. We wanted it related to the cabinet itself. So D for dimension from here to the side of the cabinet. We said that was the leg offset. We could do the same thing here. And relative to the back. There we go. And then we did do a width, right? D again for this. And that was leg width. There we go. Now we could have done this and mirrored it across. Actually, why don't we do that just for illustrative purposes here? Let's take this sketch out. So we deleted that. Now let's create a mirror line. L for line, and I want it construction again, so we'll do that. I want to pick up the center point of that to the center point of that. So that's kind of the midline between the two outside faces of the cabinet. And we can say now, let's escape out of that. Let's do a create mirror, and let's swipe over this. So we're going to take that. We've selected 8 objects. So we've got 4 lines and then 4 constraints. So those are horizontal, vertical constraints. And the mirror line we're going to use, we'll select that right there. Bingo. So we got our second leg. All right. We need to do some housekeeping over here, don't we? Let's finish that sketch. What was this sketch? Let's label that so we know what it is in the future. That's the back panel profile. And this is the leg profile. All right, we can get the rest of our cabinet turned back on. And I think I talked about making the legs 4 inches tall, so let's try that. E for extrude. We're going to pick these 2 profiles. We're going to create new components. And the distance, 4 inches. We could also drive that with a parameter. Let's put that in here. Plus leg height. And we'll put that in inches and call it 4. There we go. Now we can come back and right click on that and edit feature. Now instead of 4 inches, we can change this to leg height. So that'll change if we go back and edit those parameters, which we're going to do here in just a minute. So let's label this. This is our leg components. Now let me just illustrate why we did all these parameters. Let's say the client said, you know, I made a mistake. The cabinet really can't be more than 300 millimeters deep. So let's change that and watch what goes on here. So our whole cabinet got slimmer. And notice that the legs, because we defined them as an offset to the sides, front and back surfaces, those change dimensions too. If we decided we're going to make the cab height not 62 inches, but let's call it 75 and see what happens. So zoom, there it goes. And notice, again, the size of the back panel tracked with that. The grooves got recut in different positions. So that's really the beauty here of this parametric design. I'm going to go back now. This was 62, and the cab depth was 490. There we go. So we're back to the original. Those legs look kind of clunky. I kind of like elephant feet. Let's try that. Let's modify this, edit this leg creation feature here. We've got a taper angle here, so we can cause that to splay out on all sides as it goes. How about trying 10 degrees? That may be a bit much. How about 8? There we go. And they still look pretty clunky. How about if we put some chamfers or fillets? Let's do that. Let's create a fillet parameter here. Leg fillet. Sorry. Plus. And let's make those, I don't know, 20. Let's see what it looks like. We can come back and change it. So here's our fillet. So let's put fillets on these corners. Let's do, might as well do them all. There we are. 8 edges, and this was leg fillet. That looks a little better. Let's make it a little bigger. Leg fillet, let's make it 40. How about that? Okay, well, we're kind of getting there. That angle still looks a little steep to me. Let's re-edit that. Edit feature. Let's make this 5 degrees instead. Okay, that's probably a good placeholder for now. So there's our basic cabinet box. I'm going to do a couple more things here to. So I've got a couple more housekeeping things I'd like to do here. The first thing I want to do, I should have done this earlier, but let's save this. So Option or Command S on the keyboard, and that will have saved it. Let's open the data panel again, and user saved. You can put a milestone marker in here if you want. And if you notice, the version number over here, once it gets done uploading into the cloud, has now changed to version 2. You can actually go back and open prior versions if you want. You know, sometimes that becomes very helpful if you get too far ahead of yourself and need to backtrack. Fusion will also automatically capture essentially a backup. You can specify that in the parameters for your settings, so that you know, if it crashes, which you know it does not often, but enough to really irritate you when it happens, you've got something that's at least recoverable from the last 10 minutes or so. So housekeeping wise, we're going to get a little bit ahead of ourselves here, but one of the things I want to do now is join all these components together into a rigid structure as though they've been glued up together. I can grab these things with my mouse and move them around. I'll show you here. So the sides, because they're mirrored, they move together. So you can see things aren't attached. And I'm going to go up here and revert the position back to where it was. And I want to create a joint relationship between all of these things to make it so everything's attached to each other permanently. And we do that with the assemble command here. And in this case, we're going to do a rigid group. And we're just going to specify the components here by clicking on them in the browser. So, and we're going to include child components. There aren't any here, but there will be in future sessions. So it wants us to select the components that we want to create a rigid group with. So we'll just click all of the elements of the case and say OK. Now, if I try and move this thing around, it all comes together as one unit. I'm going to revert because I want it centered on the origin of the model like we started out. So that's one cleanup operation I want to do. Now that we've created this structure and assembled it together, I want to ground this thing so it doesn't move around in 3D space, because we're going to be adding things to it. It's often easy to accidentally get this thing moved around, and I don't want that happening here. So there's a way to do that here. It has to be done at one of the lowest levels in the browser tree, but I'm going to ground this cabinet bottom so that it won't move. So if you right click on there, we can pin that, and there's a little push pin that shows up there that tells you that it's been pinned. And now if I try and move things around, it's going to stay stationary, which I like because we base this off of the origin of the master bar cabinet component here, and I don't want this moving around in relationship to that origin. So another housekeeping thing I'd like to do here, got a couple things in mind. First, I want to get the materials set up properly here for this thing. Let's turn off the display component colors here thing. And if you look at this, what do we got here? Well, I have a preference set up. If you open your preferences panel, you can specify what your default material is. So I had this set up for metal, steel with an appearance category of steel with a satin finish. That's clearly not what this cabinet is. This is cherry. So, you know, we just created a steel box, but we can change that. Let's modify the physical material here, and you know we have lots of things to choose from here, including wood. So we could drag cherry over here and put that on the case, and it brings an appearance with it as well. And why is that interesting? Well, here's why. Obviously we get appearances that are better. They're not perfect. We can fine tune that later. But one of the things I'm curious about is, what does this thing weigh? Ultimately, it's going to have to be moved. So I'd kind of like to know what we're dealing with here at this point. So we can right click on this and get properties right here. So this is the mass. And since I'm working in imperial units, we've got this in grams. So we got 36 kilograms and 36,076 grams. So 36 kilograms is 2.2 pounds to the kilogram. So this thing weighs something like 80, 85 pounds as it sits right now. Now, obviously, we told it was solid cherry back. That isn't true. It's going to be plywood. I don't know if that weighs more or less than cherry. I would assume it weighs a little bit less. But we've got an 80-pound thing here, and we still don't have any doors or drawers in it. Anyway, that's one thing I wanted to show you. I should have set up the preferences here at the beginning to specify the category here is wood, and we're working in cherry, and the appearance category we're going to use when we're all done is wood, and within that we're going to do cherry semi-gloss. So apply, and everything we do from now on until we change that setting again will be based on those default settings, so we won't have to go in and do this. But we can keep track of how this thing grows in weight. Okay, so I think that's our cleanup operation. Okay, well, I think that's about it. We're going to do one last save here, and if you like this or don't like this, feel free to hit the thumbs up or thumbs down button below. Subscribe button there too. Subscribe if you like. Also, you can leave comments. The next episode will be following on from here to create the drawers. We're going to start with a separate model to create drawer boxes and use those to import into this model. And over the entire course here, we're going to end up putting in lighting and actually making drawer slides function and things of that nature. So follow along if this is of interest to you, and thank you for watching. I'll see you on the next episode.